Hi guys, am I audible and visible? Can you see me and hear me? Yes, I am. So what's up guys, how are you all? Very good evening once again. Today we have met twice a day, isn't it? That's overdose of my face, is it? Is that overdose of my face? What do you all think? Or no? No, you all like my face, huh? Anyway, so like I always say, everybody, namaskara everyone. Andariki namaskaram, ellargu swagatam. This is me, your master teacher Nabamita Bhattacharya, and a very warm vanakkam to Vedantu JEE English channel. So shall we start? So bachos, my name is Nabamita Bhattacharya. As you all can see, Nabamita Ma'am. Yes, Nabamita, since I'm a Bengali, so you pronounce it as Nabamita. And today we are doing some power PYQs of chemical bonding chapter. You know that chemical bonding is one such chapter from where 2 questions are guaranteed, and if 2 questions are guaranteed, that means that 8 marks guaranteed. So how many of you are ready for the session, everybody? Theory will come tomorrow. Tomorrow we will do the theory. Now quickly go ahead. Why power PYQ before flash? So there has been a little bit of slot exchange, right? So you know that my flash slot did not come up, and we wanted to make sure that we take our sessions right on time. So that is why I'm doing it today. Okay, what about chapter 2? Which chapter 2? Which chapter 2? I don't know. Chapter, you can't tell me chapter 2 and all. Chapter 2 and all we do not know. We know the chapter name. You tell me the chapter name, then we will talk about it. Theory of chemical. Okay, so guys, everybody have a look at the schedule. Okay, now tomorrow, Thursday, chemical bonding will happen at 6 p.m. when we will be doing a flash series. That means we will be taking care of the concepts, we will be taking care of the theory, and we will obviously solve questions that are required for us to understand the concept, right? Now today we will be taking a look at chemical bonding previous year question. Now I know that many of you are scared, okay? Many of you are scared that, ma'am, without the theory, how do you expect us to solve the problem? Virtual slap and punch, virtual punch, that you will get. You know why? Because if you are waiting till the last minute and you still haven't studied anything, then the dream you have to reach IIT, forget about it. I believe I have taken chemical bonding. I think I am the only teacher who is still in this channel, and I know since the beginning of the academic session I have been helping you. Now you have already seen, or you have already watched the video of chemical bonding that I have made. I've also taken PYQs a lot of times. So yes, I have completed PYQ in the last couple of months. However, I will take the session once again for your sake. So don't tell me that, ma'am, you did not take the session only, how will we solve problems? That and all, if you say no, one virtual punch you will get. Okay, all right. Yes, I have taken this chapter before. Of course, I have taken this chapter before. How can you say that I have not taken the chapter? What was I doing all the academic session, huh? So chalo, are we ready, everybody? Shall we start with the session, guys? What do you all say? Shall we start? We have a couple of questions. Not couple of questions. Why will I solve only 2 questions, right? We have around 25-30 questions today that we will solve, and after solving them we will see how many marks we are getting. So now what I want you all to do is, after every question that you are done with, okay, after every question that you are done with, how about you let me know in the chat box that, ma'am, +4, okay? And if you are getting it wrong, then write down -1. Don't be sad, it's okay. We will take a look at it. Chalo, okay? Yes, I will explain from the basic, don't worry about it. So now let us start with one question, okay? And in fact, while we are doing the question, also I will explain the concept. Don't worry, it will be a good revision. You will be revising twice, okay? All right, everybody there? Chalo. Now, let us talk about order of covalent bond, okay? Now, in this chapter called as chemical bonding, we do learn about a very famous law. This famous law is written as FAJANS, but it is pronounced as faience. What do you call it? You pronounce it as faience. It's not fajans rule. That's what most of us Indians say, but it is actually faience rule. Okay. Yeah, just like how people say de Broglie, right? It's not de Broglie, it's de Broglie. Yeah, these are all like different countries, different pronunciations. So here you have a Fayan, right? Now Fayan gave us certain rules, right? And he said that based on a cation or anion, you can talk about their polarization, you can talk about the covalent character and all of that. Now, if it is an anion, right? Mr. Fayan said that if it is an anion, right? If it is an anion, then in case of an anion, what happens is, in case of an anion, what will happen? Check it out, bachu. You will have size. Size will be directly proportional to the polarization power. That means that if the size of the anion is bigger, then the polarization capacity will be more. If the size of the anion is smaller, then the polarization will be lesser. Size is also directly proportional to the covalent character. Okay? It is directly proportional to covalent character. Alright? Yes, everybody? And when we talk about cations, right? When we talk about cations, we see that size is inversely proportional to polarization. Alright? And it is inversely proportional to CC, that is covalent character. Okay? It is covalent character. Okay? Yes? Then you have, so you understand, right? You understand. But this was only size. Let's talk about charge. What happens to the charge here? Have a look. Charge in case of cations is directly proportional to, obviously, polarization, and it is directly proportional to covalent character. Are you getting my point? Yes. Now, after looking at all of this, now let's have a look at what the question is asking. So the question is asking, you have to say true or false for each of the couples that you see. Like for example, KF and KI, LIF and KF, KF and KI, LIF and KF. You have to talk about this. If it is true, it is true, it is false. If it is true, it is false. And then you have to tell us the correct answer, right? Now, as per this rule that we have written, correct? As per this rule that we have written, now we see that in case of KF and KI, how will KF and KI break, bachos? KF will break as K plus F minus, KI will break as K plus I minus. Now, the cation is similar in both the cases. So, cation is nullified then. We do not have to talk about we do not have to talk about the cation at all, because K plus, similar, right? We only have to talk about F minus and I minus. Now you tell me, F and iodine, fluorine and iodine, which one has a bigger size? Which one has a bigger size, bachos? Which one has a bigger size? Iodine has a bigger size. So is it going to be true that iodine will have a lesser polarization? No. That means that KF greater than KI, that is wrong. Now let's talk about LIF and KF. In case of LIF and KF, we see that the anion is similar. In both the cases, you have fluorine and fluorine. Now the cations are different. You have lithium one place, you have potassium one place. Now tell me, lithium has a smaller size or potassium has a smaller size? What do we know? We have lithium, sodium, potassium. Lithium has a smaller size. So that means that this is true, bachos. LIF is greater than KF. LIF will have a greater covalent character than KF. Understanding everybody? Understanding everybody? Great. Moving on, everyone. So now the option number B, check it out. Option B, KF is less than KI. Yes, that is true, because we have just solved it in the previous question, isn't it? Yes. LIF and KF, that is true. Absolutely. So option B is proper, pakka correct, right? Okay, great. Now have a look at SnCl4 and SnCl2. Acha, SnCl4, SnCl2. Now you can see, and you must be confused that, ma'am, but in this case, the cation and the anion are exactly same. True. but the charges are going to be different, isn't it? In case of SnCl4, if I write, that means this will break and this will be Sn plus 4 here, and here you have SnCl2, so that means this will be Sn plus 2, correct? So that means that now see, in case of cation, charge is directly proportional to polarization. That means that if there is more charge, then obviously it will have more polarization. So option C is correct. SnCl4 is greater than SnCl2. This is right. Talk about CuCl and NaCl. Achha, here in this case, we have a different kind of concept that we need to use. That I do not know if you have studied or not studied. Have you studied something called a pseudo noble gas configuration? Guys, please listen and pay attention, everybody. Instead of chatting it up, call up your friends. Yes, if you find it boring, just don't go, because trust me, this is going to be important for you. You will be able to solve the questions. It's very important. You are going to get 2 questions from this chapter, and if you pay attention here, you will definitely bag 8 marks in your pocket. So please listen, yeah? Please listen, guys. Okay? Now, do you know something called a pseudo noble gas configuration? What is the pseudo noble gas configuration? So we all know that noble gases or the inert gases, right? Noble gases or the inert gases, why do they have a chemically inert nature? Because they hold 8 valence electrons, right? They have 8 valence electrons. Now, in case of this pseudo noble gas configuration, we see that the configuration of an ion, of an element, in which the shell with the highest energy, that is the last shell has, that is 3s, 3p, 3d together. This will be the last shell, right? 3s, 3p, 3d. Together they have 18 electrons. If they have 18 electrons, then we call that to be pseudo inert gas configuration. Now, if you don't believe me, let me show it to you, okay? Let me show it to you. I know, yes, many of you have told me that the answer is option C. Very good. Now have a look at NaCl. If I break down NaCl, I will have Na plus and Cl minus, right? Yes. So for Na plus, what is going to be my electronic configuration? It is going to be 1s2, 2s2 and 2p6. Here I have 8 electrons. True. Now have a look at CuCl, my dear bachos. Cu will break down as Cu plus Cl minus, right? Here, if you write down the electronic configuration, you will find that it is 1s2 and 2s2, 2p6, 3s2, 3p6 and 3d10. Now together you see there are 18 electron in the outermost shell. There are 18 electron in the outermost shell, and that means that this will have a pseudo noble gas configuration, which is why the option C is also correct. Okay. Now moving on, once again you can clearly see that LIF is greater than KF. Yes. CuCl, NaCl, wrong. KF is lesser than Ki. Yes, that is true. CuCl is greater than NaCl. That is true. So yes, option C is the correct answer. Everybody, do we get it? Do we get it? Spirit, sleep, sleep, sleep. Sleep, bacha, sleep. Not my loss. It'll be your loss. If you want to sleep now in this class, it's not going to be my loss, bacha. Seriously, promise. Don't do all of that zzz and all. Huh? What are you doing? You think that I'm not tired? I'm also tired, right? Huh? Yes? Okay. Alright. Now, talking about, you might also ask, there is another question that may come in. See, I am talking about absolute basic. You guys just told me that, ma'am, please start taking from the basic, right? So, I'm taking it from the basic. Now, you might ask that, ma'am, just because they have filled up the d orbital, why do they have more polarizing power? By chance, if you want to ask. Let's say that this d orbital is filled, you can see, and that is why I'm telling you that they have pseudo-inert, pseudo-noble gas configuration and they have more polarizing power. But you might ask that, ma'am, why? Why do they have more polarizing power? Now, bachos, tell me, how many of you know that d orbitals, they have the weakest shielding power, isn't it? Not weakest, but I mean the second best weak, right? F orbitals have the weakest. D orbitals they also have weak shielding power. If they have weak shielding power, obviously the electron is closer. That means that they can also reach out to the Cl electron and pull it closer. More polarizing power. Makes sense? Yes, more polarizing power. Doesn't that make sense? It does. Chalo. Moving on to the next question, everybody. Decreasing order of the hydrogen bonding following in following forms of water is correctly represented by. Okay, now when you look at this question, tell me what comes in your mind. Look at this question and laugh. Everybody, I want laugh reactions, please. Now, volume is very low. No, that's not possible. How is that possible? That's not possible. Volume is not low. I can hear myself clearly. I can hear myself absolutely clearly, guys. Pradeepa, can you please increase your volume? Yes, I want laugh reactions, guys. I really want laugh reactions. Yes, everybody. You look at this question and see, tell me, this has come in JEE Mains 2023. I mean, who asks this question? Who asks this question in JEE Mains, everybody? Nobody, right? It's so weird. Okay, so that means obviously ice will have the highest, right? Ice will have the highest hydrogen bonding. Then it will be liquid water and then it will be impure water. Now you might ask, your phone has a problem? No, ma'am, something went wrong. Guys, is everything clear? Is everything fine? Is there a lag issue? Is there a volume issue? What is going on? Everybody, are you all able to see me and hear me? Are you all able to see me and hear me? Something is going wrong or what? Please tell me quickly. Please tell me quickly. Am I audible and visible or is there an issue? Is there any issue? Is there any issue, guys? Or am I absolutely audible and visible? Can I please? Clear? Thank you, Mr. Gamer. Thank you, Vaishnavi. Thank you, Pradeepa. Thank you. Okay. All right. So we are fine. Yes. Now, you might ask me that, ma'am, impure water and liquid water, why is there a difference in the hydrogen bonding? Well, that's because of the impurity. Yes, because of the impurity that exists in this impure water, the hydrogen bonding decreases. Okay, so let me just write one line here so that you remember. Due to impurity, what happens? Extent of hydrogen bonding, extent of H bonding decreases. Okay, extent of H bonding decreases, and that is why our answer is going to be B is greater than A is greater than C. That is option B, right? Okay, chalo. Now everybody, we are going to have another question. Are you all ready for the next question? The next question is, what is the number of unpaired electrons in the highest occupied molecular orbital of the following? Yes, the following species are N2, you have N2 plus, you have O2, just O2, and you have O2 plus. So, chal, yes. Let us have a look at it, okay? Let us have a look at it. Now, for these, these species, your molecular orbital theory is going to look like, everyone, your molecular orbital theory is going to look like, everybody, sigma 1s, right? Sigma star 1s, right? Then you will have sigma 2s, sigma star 2s, right? Then you will have sigma 2s. Then you will have pi 2p x, which is going to be equal to pi 2p y. Yes. Then you will have, what will you have? You will have sigma 2p z, isn't it? Sigma 2p z. So ideally, this sigma 2p z is going to be your highest order molecular orbital theory. Yes, isn't it? Or highest occupied molecular orbital theory, which we also abbreviate it and we say that it is called as HOMO, right? And lowest occupied molecular orbital theory is LOMO, correct? Yes. So this is our ideal scenario. Now let us write it for each and every one of them. Okay, let us write it for N2 plus. Okay, let us write it for N2 plus. For N2 plus, what will we have? We will have sigma 1s2, we will have sigma star 1s2, then we will have sigma 2s2. Yes, then we will have sigma star 2s2. Yes, sigma star 2s2. Then what will we have? Everybody, come on guys, reply. Yes, After that, what will we have? After that, we will have pi 2px2, yes, which is equal to pi 2py2, and then we will have sigma 2pz1, and this becomes our highest occupied molecular orbital. This becomes our HOMO, right? Now when we come to O2, for O2 what will we have, guys? For O2 what we will have? For O2 also, if you continue like this, you will see that there are there are two electrons in the highest occupied molecular orbital. Please do it and find it out. Yes, then you do it for O2 plus, then you do it for N2. You will find out that the answer, my dear students, is option number 1, because in N2 there will not be any electron in the highest occupied molecular orbital. It will be 0, 1, then 2, 1. Okay, it will be 0, 1, 2, 1. Do you guys know how to write down the molecular orbital theory? Everybody, do you guys know? If you do not know, don't worry about it. Come tomorrow. Tomorrow at 6 p.m. right at this time, I will be taking the concept plus theory plus questions lesson. Please be there so that you understand all of these things absolutely crystal clear. Clinical clear it should be, okay? And after the class, you should be all able to tell me that, ma'am, hashtag EPBT, ma'am, hashtag EPBT, right? Yes. So does this make sense, guys? Does this make sense or no? Does this make sense or no? Guys, I need your answers. Please, yeah, chat up, interact with me. What are you guys doing? Huh? No talking and all. What are you guys doing? Okay, no one is going to talk? Great, cool. Don't talk to me. Fine. Don't talk to me. Fine, fine. Don't talk to me. Chalo. Let us go to the next question. The next question, everybody, is that given below are two statements. You are given here two statements. Have a look at them. One is called as assertion and the other is labeled as reason. Okay. Now, in the assertion, they are saying that benzene is more stable than hypothetical cyclohexatriene. Okay. Benzene is more stable than hypothetical cyclohexatriene. This is a true. This is a true fact. Okay. All right. Then what happens is, no, please calculate for O. Acha chalo, I'll get back and I'll calculate. Okay. Then what do we have? Then it says that reason the delocalized pi electron cloud is attracted more strongly by nuclei of carbon atoms. That is also true, Baba. That is also true. So both the reason and the assertion are correct, and actually the reason is the correct explanation of the assertion. So I believe that it should be option C. Yes, I believe that it should be option C. Very good. Acha. So many of the students are telling me that, ma'am, we want you to calculate it for all these HOMO that we are not able to calculate. Are we also thinking in the same term? We are. Chalo. Then let me do it for O2 as well. Yes, let's do it for O2 now. So I'll stand this way so that you can clearly see it. Now can you clearly see it? If I stand this way, then you see it, right? Yeah. Then you are able to see it. Okay, chalo. What is meant by delocalization? Allah, I will have a heart attack now. I will seriously have a heart attack. What are you telling me? Less than 1 month left for your exam and you are asking me, ma'am, what is delocalization? Okay, chalo, delocalization means that actually the electron cloud does not stay at one position. It moves around, right? And whenever there is a double bond, we say that the first bond is a sigma bond and the second bond is a pi bond. So the double bond that you have in the benzene ring, they are not at one position only. It keeps moving around. The electron cloud keeps moving around. So this pi electron, because it is not local, it is not staying at one place, it keeps moving around. Hence it is called as delocalization. But I don't know what you're thinking about. But anyway, now let us do it for oxygen. For oxygen, we know that it is going to be sigma 1s2. It is going to be then sigma star 1s2. Sigma 2s. Acha, you know what? Let me show you, okay? So what you can do is just write here Just write it like this, okay? You have sigma 1s, sigma 1s, sigma 2s, sigma 2s, okay? Then what do? Then you write sigma 2pz, okay? Then you write here pi 2p, pi 2px is equal to pi 2py, yes? And then you have pi 2px is equal to pi 2py. This is how you write. Now what you can do is, see, sigma 1 is, now write here 1s2 star 1s2, sigma 2s, sigma star 2s2, sigma 2pz2, sigma, pi 2px 2, pi 2py2, then it becomes pi star 2px1, pi star 2py1. Now you might also ask me that, ma'am, why did we do this? How many electrons should be there in oxygen O2? In O2 there should be 16 electrons, isn't it? 16, 8 plus 8, 16 electrons. So calculate. 2 plus 2, 4, 4 plus 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See, I have put 16 electrons. Did you see? So this is for your O2. Now O2, you will see that this is the highest occupied molecular orbital. Okay. Now if we do it for O2 plus only they have asked, right? For O2 plus, once again you write it like this. Sigma 1s, sigma 1s, sigma 2s, sigma 2s, sigma 2pz, then it will be pi 2px is equal to pi 2py. Then what will we have? We will have pi star 2px is equal to pi star 2py. Okay. Then what you do here? Star 1s2, 1s2, here 2s2, star 2s2, sigma 2pz2, pi 2px2, 2py2, 2px1 and 2py0. O2 plus, that means 1 electron is less. 1 electron is less. So this becomes your highest molecular orbital, highest occupied molecular orbital. And now do you understand? It will be 0, 1, 2, 1. Yes, is this clear? Now is this question clear, everybody? This question is clear, guys? Chalo. Shall we move on? Let us move on to the next question then. Let us move on to the next question, shall we, everybody? Come on. Are you all with me? Everybody, are you all with me? Next question is statement 1. Dipole moment is a vector quantity and by convention it is depicted by a small arrow with a tail on the negative center. That means it's like this small arrow and with a tail may you put a negative center and head pointing towards the positive center. Now, statement 2 says the crossed arrow of the dipole moment symbolizes the direction of the shift of charges in the molecule. Does it? Does it? Can somebody tell me? What is the answer? The answer, my dear student, is no. Both the options are not correct. Yes, statement 1 is correct, but statement 2 is incorrect because this does not. Statement 2, have a look. It says that it depicts this particular diagram that we have, an arrow with a negative cut here. It does not show the shift of the charges. What does it show? Does anybody know what does it actually show? It shows, my dear bachos, it shows, what does it show? It shows the shift of electron density in the molecule. What does it say? Here it is saying shift of charges in the molecule. No. What does it actually show you? It shows shift of electron density. Shift of electron density. Okay, shift of electron density. That is what it actually depicts. Okay, all right. Yes, got it. Why is this class started directly from PYQ? Acha guys, you guys don't follow the channel or what? Huh? You guys don't follow the channel or what? I mean, seriously, I'm surprised by the questions that you are asking. Shreya sir had told you, right, that we will have 2 series. We will have a power PYQ series. We will have a flash series. And the third one is your marathon series, right? Right, everybody? Now, today I am doing power PYQ. What did the thumbnail say? In the thumbnail also it was written PYQ. Why first PYQ? That's because I'm the only existing teacher in this channel. And I have taken these sessions. Okay, I have taken care of chemical bonding. Shreya sir and Nabamita Ma'am are new to this channel. I mean, not new, but yeah, they are new to the channel. So they have a lot of things to cover, but I have covered, right? I have taken care of these sessions, right? Haven't I? Are you going to complain that, Ma'am, you haven't taken chemical bonding? Go and check. I have taken chemical bonding long time ago. It has already 1 lakh views also. 1 lakh students have already observed it. You haven't observed it. Go and watch it, bachos. Please go and watch it. Okay. So have we understood this question, guys? Shall we move on to the next question? Let us move on to the next question. What do you all say? Yes? Yes, yes, yes. What do we think? Shall we move on to the next question or no? Okay, again, nobody is going to talk to me. Great. It feels like you guys don't like me anymore or what? I don't understand. Hello, attitude status. Hello, hello. Now, according to molecular orbital theory, the bond order for O2, 2 minus, carbon monoxide and NO plus respectively are. So, bachos, what are we going to do? What are we going to do? Are we going to actually write down the, sigma 1 as sigma star 1 as sigma 2 as sigma star 2 as? Are we going to sing a song and write it down like this? No. We know a very chotu trick and we can do this very easily, right? How can we do this? See, O2, how many electrons are there in O2? In O2 you will have how many? 8 plus 8, 16 electrons. So 2 minus, that means you will have 18 electrons. So in 18 electrons, bacha, how do we calculate the bond order? For I have taught you, right? I have taught you, isn't it? See, what we do is, initially, first of all, we write here 14, okay? If we write here 14, then for 14 electrons, the bond order is going to be 3. Bond order is going to be 3, okay? Yes, now if you write here 15, for 15 it will be 2.5, for 16 it will be 2, for 17 it will be 1.5, for 18 it is going to be 1. Now here go, 13 will be 2.5, yes, 12 will be 2, 11 will be 1.5, and if it is 10 then it will be 1. So clearly O2, 2 minus, O2, 2 negative will have 18 electrons. If it is 18 electrons, then the bond order is 1, right? Now, for carbon monoxide, carbon has what? 6 electrons in the outermost shell, oxygen has 8 electrons, right? So that means 6 plus 8 is 14. 14 means bond order is 3, right? For NO plus, 7 plus 7 is 14. So 14, that means that the bond order is once again 3. So option number A, that is 1, 3 and 3 is the correct answer. Yes? Yes? Did we do it? Wasn't it very easy? Was it not very easy? This is the trick. You have a trick, you use the trick and you calculate it. You don't have to go through sigma 1 as, sigma star 1 as, sigma 2 as, sigma star 2 as, and then you calculate how many bonding electrons are there, how many anti-bonding electrons are there. Then you subtract, then you divide, and then you find out who wants to do that. Who wants to do that? Nobody, right? JEE Jamkai. Arey bacha. Shh. Once again, I'm telling you, it's not like I haven't taken the session. I have. Okay. So your tomorrow's chemical flash series is going to be a repetition. I expect you to already know this chapter should not be new to you. Okay. I really hope that this chapter is not new to you. And please stop asking the same question, guys. Study now. Huh? Why are you questioning our tactics and tricks right now? Study. Pagloos, study, okay? Study. Very less time is there. Instead of thinking that why ma'am is taking like this, why ma'am is not taking this question, why ma'am is doing this, forget about all these things. Just study right now. That's your job. Let the planning and plotting and everything that we do, let that be for us. You study, okay? You study. Yes, you can apply to the previous question also. Yeah, you can. You definitely can. But in the previous question, I thought that I will tell you the concept first. So I told you the concept. Now, chalo, let us have a look at this matching list, everybody. Okay, so we have to do what? Matching. IF7. IF7 will have number of lone pairs on the central atom, guys. Number of lone pairs on the central atom. Chalo, let us figure it out. For IF7, how do we draw the structure? Iodine. Iodine belongs to group 17. Group 17 will have 7 electrons outside, right? So have a look. IF7, 1. And then you have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 and 7, right? Is there any lone pair? Do you see any lone pair here? 0. So IF7 will have 0 lone pair. Now we will write about, this is your IF7, okay? This is your IF7. I don't know, can you guys see it? I hope you can see it. Chalo. Next everybody, let us do it for ICl4 minus. For ICl4 minus, we will draw I here. Cl, 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 Cl. Yes, Cl, Cl, Cl. And then what do we do? 4 minus, right? So that means we will have one lone pair here. So 1, 2, 3, 4, 5, 6, right? Then we will have to do 7 and 8 because it is 4 minus. There is a minus here. So that means 2 lone pair. So ICl4 minus comes to option 3. Great. Now, XEF6, but choose XEF6. So how do we draw this? We will draw it like 1, 2, 3, 4, 5, 6, and here there will be a lone pair. So it will be F6 all the way around. Write down F here. This is your answer. So F6 will have 1 lone pair. That means that XEF2 is definitely going to have 3 lone pairs. So this corresponds to which answer, everybody? Can you please tell me? This corresponds to which answer? This corresponds to which answer, everybody? Yes? Please, please, please go ahead. Write it down. Write it down. What is the answer? You have A goes to 4, B goes to 3. No, B goes to 2. B goes to 3, A goes to 4, B goes to 3, then C goes to 1, C goes to 2. Option B is the correct answer, is that right? Option B is the correct answer, is that right? Yes? Very good. Option B is the correct answer. Great, great, great. Everybody got the right answer? Yes? Everybody got the right answer? Yeah? Okay. Vicky Gupta, you are writing that you are in depression, but I'm so sorry that you're going through this. Number one, I am a teacher, yeah. I am not a professional. I'm not a professional here. So I don't think I will be able to help you with depression. I can probably talk to you about a little bit of motivation, but I'm not a professional medical practitioner here. So my suggestion will be that please go to a professional therapist and make sure that you get better. Please do. Yes, bacha. Please go ahead, consult a therapist, take therapy from a professional. I think it will get you a lot more help than you telling me about this. Okay? Chalo. Alright. Yes. Sobi, not right now. Yeah, not right now. But anyway, your concepts plus videos and whatever we are doing, all those also are accepted for your 2025. So you can do it. Okay? Alright. Chalo guys. Moving on to the next question, everybody. And our next question here is, okay, this is again a matching question, everyone. Chalo, let's do a matching question once again. Are we all ready? Yeah. Let's do it. Now, for XEF4, what is going to be the shape, everybody? For XEF4, have a look. You will have F4 here, 1 and 2 and 3 and 4. And here you have a lone pair. Here you will have a lone pair. Don't look at the lone pair. Just look at the bond pair. What is the shape, everybody? The shape, my dear students, is here square planar, right? This is going to be square planar, right? Now let's talk about SF4. For SF4, we draw the structure as 1, 2, 3, 4. This has a seesaw shape, everybody. This has a seesaw shape and we all know that, correct? Now we will have NH4+. For NH4+, this is going to be a tetrahedral shape because 1 and this 3 here, H, 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 and here you will have an H. So this is a tetrahedral shape. For BRF3, is there anything that is remaining? No, it has to be bent T shape. So this is like this, BR, F, F here, and then you have a 2 lone pair like this, okay? So now tell me what is the answer. Tell me what is the answer then, everybody. Yes, what is the answer, guys? For XCF4, we saw that it was square planar. SF4 is a seesaw. NH4 plus is tetrahedral and BRF3 is bent T shape. So A is 2, B is 1, C is 4, C4 and D3. That means option D is the correct answer. Everybody, are you all getting this? Yes? Everybody is getting this answer or not? Are you all getting this answer, guys? Everyone is getting this answer. Chalo, give me a minute. I'll just drink some water. Yes. Very good. I can see that many of you are giving me the correct answer. So does this look like jujupy stuff? And please tell me how many marks have you got till now? Does it look like in chemical bonding you will be able to get 4 plus 4, 8 marks? Yes? Will we be able to get 8 marks in chemical bonding or not? What do you guys think? What do you guys think? I think we will be able to. Yay! Amazing. Chal. Next question, everybody, is, the next question is resonance in carbonate ion, that is CO3 2 minuses. Please read the question carefully. Resonance in carbonate ion CO3 2 minus is, which of the following is true? It is possible to identify each structure individually by some physical or chemical method. Really? Can you do that? Can you do that? Not at all. Wrong. All these structures are in dynamic equilibrium with each other. Is that true? Not at all. Nope, nope, nope. Each structure exists for equal amount of time. Can we even say that? No, we cannot. And finally, CO3 2 minus has a single structure which is a resonance hybrid of all the structure. That does make sense, right? That does make sense. So yes, option D is the correct answer. And look at this. This is a JEE Main 2023 question. They are asking you about resonance structure. Guys, look at this. JEE Mains does look doable, I believe. Now you probably are able to have a relief and think that yes, we will be able to do chemical bonding. What do you guys say? Yeah? Very good. Chalo. Moving on to the next question. Okay. OO bond length in H2O2 hydrogen peroxide is dash, then OO bond length in F2O2. The OH bond length in H2O2 is dash, then that of OF bond in F2O2. Choose the correct answer. Okay. So very clearly that means that we will have to explain something. Now in O2F2, we know that O2F2 has a very similar structure to hydrogen peroxide, isn't it? We know that. But the OO bond length that you have is actually shorter because we all know that fluorine has a very high electronegativity, correct? Yes? Fluorine has a very high electronegativity, correct? So that is why what happens is the OO bond becomes shorter here. What happens? The OO bond becomes shorter here, right? Yes, the OO bond, I mean the OO bond in O2F2 is shorter. So the OO bond length in H2O2 is longer, it will be. We will write it as longer than OO bond length in O2F2, right? Now what happens is, we all also know that according to the Bent rule, in covalent, in this, chemical bonding chapter, we have read about something called as, Bent rule. And in this Bent rule, we have learned that the more electronegative atom, they have less S character. So what happens? The bond length increases. That means that the OH bond will be shorter than the OF bond. Are you getting it? Yes. That means that the OH bond is going to be shorter than that of the OF bond in F2O2. Hence, we will say that option D is the correct answer. Yes. Hence, we will say that this is the correct answer. Are you guys listening? Anybody? Everybody? Are you guys listening? Or no? Nobody is listening, huh? How to draw structures with your hand, bacha, with your hand. What else? How do you draw structures, huh? Practice. That's the only answer that you are going to get. If you want to clear JEE, if you want to be better in your studies, you have to practice. You practice your previous year questions, you practice the concepts. You have to practice. This is the only answer. If you are thinking that I have some secret weapon to tell you, nothing. Nothing. And if anybody is, don't believe them. The only way you can do something is practice. Okay? Alright? Yes? Anju, why, bacha? I'm doing something, no? Have a look at it. Focus, please. Please focus. Okay, let us go through this question once again because many students are asking. Okay, many students are saying that, ma'am, we're not able to understand this. So, chalo, let us talk about it. See, acha, does everybody know what is the structure of hydrogen peroxide? Yes. Structure of H2O2, do you know? Structure of H2O2, does anybody know? The structure of H2O2 is actually like a book. Okay, it is like a book, like this. So one OH is here and the other OH is here. It's like a book. So basically the structure looks like this. O, here is O, then you will have H here and you have an H here. Okay. So we are talking about this OO bond and the OH bond. Are you getting my point? Yes. This OH bond and we are talking about this OO bond. Alright. Alright. So what I am telling you is that, my dear students, that hydrogen peroxide and O2F2 have a similar structure. But what happens with the OO bond length? This OO bond length, what happens to it is, it becomes shorter in O2F2, longer in hydrogen peroxide. This OO bond is longer in hydrogen peroxide. Why? Because we understand that hydrogen is less electronegative than fluorine. Are you getting my point? Now do you understand? Fluorine, because it is electronegative, what does it do? The bond length becomes shorter. Okay? Similar to this, now what happens is, because fluorine is more electronegative, we understand that fluorine has less S character. So what happens? There, the OF bond, that is this, instead of H, instead of OH, if I write it like this, if here you have OF, this OF bond length is going to be what? This OF bond length will be, are you getting my point? So OH bond length in H2O2 is shorter than that of OF. Here OF bond becomes longer. OF bond becomes longer. Now are we clear? Yes? Now are we clear? Silver storm gamers, bachu, states of matter does not even exist in your paper anymore. Where are you lost? Huh? States of matter, solid, liquid, gas, and nothing is there in your paper. That chapter has been deleted by JEE. Huh? That chapter has been deleted by JEE. Ye dekho, ma'am, you did not wear makeup and lipstick today. Why? Because I thought that I look pretty like this also. I thought that I'll show you my real face today. That's why. What kind of questions you ask, bacha? Focus, no. Why do you have to ask all of these stupid questions? Huh? Also, my bad that I'm answering the stupid questions. I should not be answering the stupid questions. Chalo. Moving on, guys. Next question is, the total number of lone pairs of electrons on oxygen atoms of ozone. Chalo, let's draw the structure of ozone. Okay, let us draw the structure of ozone. For ozone, how do we draw the structure? So we have O here, double bond O here, and we have a single bond O here, right? Now, if we try to have a look at the electrons, the lone pairs. So here we will have one lone pair, yes, and we will have a plus sign here. Here we will have 1, 2, 3, 4, right? So 5, 6, 7, 8. This will have two lone pair. This one has 1 and 2, right? So that means 3, 4, 5, 6, 7, 8. So that means if we count the lone pairs, we have 1, 2, 3, 4, 5, 6. There are 6 lone pairs present on oxygen in the structure of ozone. Yes, in the structure of ozone. Do we get it? Do we understand this? Yes. Was this easy peasy biryani tasty? Guys, I'm not seeing any EPBT, yeah? I'm not seeing any hashtag EPBT. What do you guys think? How will I get the motivation to take the class now, huh? There is no EPBT and all. Nobody is saying hashtag EPBT. Write down easy peasy biryani tasty. Otherwise, I'll stop taking class now. I will stop taking class. You guys are very badmash, very pagloos you are. That is why Shreyas sir calls you what? Warrior Pandus. You are Pandus only. You really are Pandus. Thank you, Achiever. EPBT. EPBT means easy peasy biryani tasty. It is easy peasy biryani tasty. EPBT. EPBT. Very good. Finally, somebody is writing. Okay. Now, the number of molecules or ions from the following which do not have odd number electrons are. Look at this. These are all jujube stuff. Absolutely jujube stuff. They are asking you which ones do not have odd electron. All you have to do in JEE main paper is to calculate the number of electrons. That's what they are asking you. Only thing they have asked you is calculate the electrons and tell us which one does not have an odd number. Can you imagine? Chalo, let us calculate. For NO2. For NO2, you will have 2 oxygen. So 2 into 8. 2 into 8 is 16. 16 plus 7, how much? 16, 17, 18, 19, 20, 21, 22, 23. 23 electrons. 23 electrons, that means this is odd. Done. This is not going to be the answer. ICl4. For ICl4, we have 7 plus 7 into 4. But because there is a minus sign, that means we will also have to add 1 electron. So 7 fours are how much? 7 fours are 28. 28 plus 7 is how much? 28, 29, 30, 31, 32, 33, 34, 35. 35 plus 1 is 36. 36. This is even electron. This has even number of electrons. So this is an answer. Now let's go to BRF3. For BRF3, what will we have? We will have again 7. 7 plus F3, right? So 7 into 3. 7 into 3 will have what? 7 threes are how much? 21. 21 plus 7 is 28, right? 28. So 28. This is also even number of electrons. Great. Now we go to ClO2. For ClO2, what do we have to do? 7 plus 8 multiplied with 2. If we do, we will get 23. So that means this is not the correct answer. For NO2 plus, if we do, that means nitrogen. Nitrogen is how many electrons? 7. 7 plus 8 plus 8 is 16. So 16, that means 23. So 23, but NO2 plus, that means 1 electron we just have to reduce. 1 electron less if we write, that means 22. If it is 22, that means this is also even number of electrons, right? And finally, we have NO. NO, we will have 15 number of electrons. This is also odd electrons. So how many? The number of molecules or ions from the following which do not have odd number of electrons are 3. Yes, we have 3, those which do not have odd electron. Okay. We want this kind of questions in organic. But yesterday only Pahul sir has taken. You guys did not see. Chalo, I'll show you. Have a look. Have a look. See? Yeah. Have a look. You people are... See, let me show you. This is our channel. This is our channel. Now, right here, everybody. See, everybody, have a look. Here. Yesterday night, Pahul sir has taken GOC and isomerism, power PYQ. See, power PYQ. Right here it is. On the top, it's right here. See, guys, power PYQ is written. That means this was a PYQ session. Pahul sir has taken GOC and isomerism. Okay. Then you can see here reaction mechanisms of haloalkanes he is going to take on a flash series. That would be 29. That is day after tomorrow. Day after tomorrow at 6 p.m. sir is going to take reaction mechanisms and haloalkanes. Have a look. You guys are not following. Ma'am is going to take sequence and series here. Sir is going to take current capacitors and AC. Tomorrow I am going to take at 6 p.m. chemical bonding flash series. So see, we are doing. All you have to do is be present and follow the channel. Okay. BRF3 ka 28 kaise? Hey, bromine. Bromine belongs to which group? 17. 17 will have how many electrons in the last shell? How many electrons in the last cell? 7. Now 3 into 7. 7 3 सब रॉन्ग पढ़ा रही है. एक मार खाओगे बच्चे, एक मार खाओगे. हाँ, तुमको बड़ा आता है. चलो गिन के बताओ. 7 3 कितना होता है, गिन के बताओ। सब रॉन्ग पढ़ा रही है, इट सिम्स। एक मार खाओगे पागल, सब रॉन्ग पढ़ा रही है, वाह। 7 इंटू 3 कितना होता है, 21। 21 प्लस 7 कितना होता है, सब रॉन्ग पढ़ा रही है, एकदम मार खाओगे। यू डोंट नो, से दैट। तुम्हें नहीं पता ये बताओ, टीचर के ऊपर सीधा कि सब रॉन्ग पढ़ा रही है, मार खाओगे। वर्चुअल पंच जानते हो, वो मिलेगा। लिखा भी है यहाँ पे कि कैसे हुआ। आई हैव रिटन इट हियर। 7 देयर आर इन फ्लोरीन। भाई कैलकुलेट, यू गाइस कैलकुलेट, कैलकुलेट एंड टेल मी, कैलकुलेट, कैलकुलेट। चलो कैलकुलेट, एवरीबॉडी कैलकुलेट। Let's see, calculate and tell me which of them are wrong. Go ahead, calculate. Calculate, I'll wait. Calculate. Now let's see. Let's see, calculate and tell me. And you are questioning me, right? Ki ma'am, number of electrons in nitrogen are 5. But don't we know that an odd number plus even number will give you what? An odd number plus even number will give you odd number only, na? Oh God. Oh God. What is it? What will, these are arithmetic. Chottu, from this small classes you know. From this small classes you know, right? Please tell me. So I am not going to tell you anything. Why did you blame me? Why did you blame me that I was teaching wrong? Huh? If you do like this, and all the other students will also think like that, because you are confusing them. Just a doubt. Seriously, you guys are. Seriously, you guys are. Chalo, let us calculate once again. Yes, in nitrogen, how many number of electrons are there in the outermost shell? Tell me. How many number of electrons are there in the outermost shell? And how many number of electrons do you have in oxygen? Then calculate. I have done all the other ones. No, calculate and see. That's it. You cannot do addition or what, guys? Huh? Addition also I have to teach you. Addition also I have to teach you. JEE Main, instead of 7, I have taken 5. But I still made it correct. I told you, right? Odd number plus even number will give you an odd number. That means that even then this is not the correct answer. It's not going to be, it's not going to have odd electron, right? I mean, it will have an odd electron system. Ho, 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 ho. For this chottu arithmetic, just addition you had to do. For that you are telling me wrong padha rahi hai. Chalo, I am bad in mathematics. What about you? You still have to appear for JEE, right? You guys, seriously. Anyway, chalo, next question, guys. Next question. Okay. Amongst the following, the number of species having the linear shape is. We need to find out which one of these have linear shape, guys. Which one of these have linear shape? So, chalo, let us draw the structure again. First of all, the number 1 structure that we are going to do is for XeF2. Okay, what are we drawing? We are drawing XeF2. So we will have xenon. Yes. Then we will have fluorine here, and then xenon will have how many electrons, guys? Xenon will have 8 electrons. So 1, 2, 3, 4, 5, 6, and 7, 8. Now, if you do not look at the lone pairs, what is going to be the shape? This is going to be a linear shape, right? This is definitely going to be a linear shape. Yes, very good. Very good. Okay. Next one is I3 plus. Next one is I3 plus. Chalo, let us draw it for I3 plus. So we will have iodine here. Then let's draw another I here. And let's draw another I here. So we will have 1, 2, then 3, 4, and 5, 6. 1, 2, 3, 4, 5, 6. 5, 6. I3 plus. Yeah, there should be 7 electron, but this is I3 plus, right? I3 plus. So 1 electron less. Are you guys understanding? This will have 1 electron less. So this shape will be called as V shape. What will this be called as? This will be your V shape. It's like this, right? Again, do not look at the lone pairs, okay? Do not look at the lone pairs. Cool? Great. Okay. Now, let us draw the structure for what do we have? C3O2. Acha. For C3O2. C3O2. So, C3 let us draw. Double bond C, double bond C. C3 is done. Then double bond O and double bond O. This will also have a linear shape, right? This will also have a linear shape. Okay? Yes? Great. Now, if we have to draw it for I3 minus, but choose I3 plus we have drawn. Let's draw it for I3 minus. So, again, I here. Alright. I3 minus. Let us draw one I here. Let us draw one I here. Now, this time I3 minus, right? So, we will have one lone pair here. One lone pair here. One lone pair here. So, 1, 2, 3, 4, 5, 6, 7, 8. Done. I3 minus. Generally we have 7 electrons in the outermost shell of iodine, but because it is I3 minus, there is one extra electron. Hence, we will have 3 lone pairs and minus here. That means this is going to be linear as well. Okay, this is going to be linear as well. Now, CO2, I am pretty sure that everybody knows that CO2 is a linear shape, isn't it? CO2 is a linear shape. Everybody knows that. Chalo, let me draw that also. C double bond O here and double bond O here. So this is also going to be linear. Finally, we come to SO2. SO2, I am pretty sure that you know what is the shape of SO2. SO2 also has a V shape, everybody. So you draw it like this. S, there is a lone pair here and double bond O and double bond O. So this will be your V shape. Okay, this will be V shape. Okay. Then what do we have? BeCl. What about BeCl? Does anybody know? Does anybody know? What about BeCl, guys? What about BeCl? What about BeCl? Very good. BeCl is also going to be linear. BeCl is also going to be linear. And what about BeCl2 minus? What about BeCl2 minus? For BeCl2 minus, I'm going to draw it here. B here. Then you have here Cl, then you have here Cl, and on top of that you have lone pair here, and here write BCl minus. So this will not have a linear shape, obviously. Soumya, what are you asking, bacha? How to draw structures? How to draw structures? Come on. What are you saying? How to draw structures you're supposed to know. These are all there in the book. And tomorrow when I'm teaching you chemical bonding, I'll teach you. Don't worry. Chill. Have a look at the questions and try to solve them. Okay? Yes. So these are the answers. So that means that amongst the following number of species having the linear shape, how many of them have linear shape? 1, 2, 3, 4 and 5. There are five compounds or 5 species here which have linear structures. Of course it does, but lone pair affects the structures. Absolutely. That is why we do not look at the structure. We do not look at the lone pair. Just write it down. What do you have? I've also written the shapes, isn't it? See how you have to draw. You know that lone pair repulsion is more than lone pair bond pair, and then there is bond pair. Bond pair repulsion is very less, but lone pair repulsion is more. So the lone pair always pushes the bond pair, which is why you can see that I3 minus is linear, but I3 plus is a V shape, guys. I3 minus is linear, I3 plus is V shape. Yes, right? Can you see it? Can you see? Okay, guys, chalo. Next question, everybody, is the correct order of bond orders of C2 2 minus, N2 2 minus and O2 2 minus. I have just taught you. For O2 2 minus, how many electrons are there? There are 18 electrons, right, people? Yes, there are 18 number of electrons. So if it is 18 number of electrons, then we can straight away write that the bond order is going to be 1, right? Bond order is going to be 1, okay? What are you guys talking about? Deepak Balu, what? This is for finding bond pairs, subtract the surrounding. What are you guys talking about? Yes, Deepak, we can use formula. Yes, like I said, today we are solving the questions tomorrow when we go through the flash series, when we go through the concepts, the theory part, and we will also solve some questions. At that point of time, I will show you how to draw the structures. Do not worry about it. Now, because we are solving the questions, let us solve the questions. Can we do that? Yes. Can we do that, please? Can we please do that? Everybody, can you please focus here? I will teach you everything tomorrow. Don't worry about it. Okay? Yes. So for O2 negative, there will be 18 number of electrons and the bond order is going to be 1. Now for N2 negative, now who can tell me what is the number of electrons here and what is going to be the bond order? Here we will have 16 electrons and the bond order is going to be 2. Okay. And finally for C22 minus, we will have how many electrons? There will be 14 electrons and the bond order is going to be 3. So what is our correct answer? Our correct answer is the O2 negative will have the least bond order, then it will be N2 minus, and then it will be C2 minus. That means option B is our correct answer. Okay, option B is our correct option, right? Yes. Okay. All right, guys. Done or not? No money. I haven't studied in NIT. I have studied from IIT Guwahati. I'm a research fellow from IIT Guwahati. I haven't studied from NIT. Okay. Good evening, bacha. Good evening. How to calculate bond order by number of electrons? Hey, J. Oh God, guys. Where is your JEE 𝐬𝐬? Rewind. Watch it. I've given you the trick. Just some questions back only I have given you the trick. Okay. Are we done? Are we done with this question? Shall we move on then? Are we ready for the next question, guys? Are we ready for the next question? Are we ready for the next question, everybody? Are we ready for the next question? Come on, guys. Bacha, how can I give? What are you asking? Soumya, your desires and demands are getting too much now. Have you seen the name of the session? The name of the session is JEE Main's previous year question, PYQ. Now, I am not from NTA. I am not from the National Testing Agency. Yeah. I am taking care of the previous year questions of this chapter, chemical bonding. So how can I give the question? Whatever they have given, I'm trying to take care of those questions. Okay. So whatever questions they have provided in 2023, I am just done with those. Now we are starting with JEE Main 2022. The year 2022, whatever questions we have seen at that time, that I am taking care of now. Okay. So are you all with me, guys? Or are there more doubts like this? Are there more doubts like this, everybody? Tier 2 NIT is definitely better. It's definitely better than your private colleges, obviously. But don't worry about it. We will see where we go, yeah? Chalo, guys. Now, read the question. Read the question, everybody. Read the question, everyone. All the people, read the question. Bonding in which of the following diatomic molecule becomes stronger? Yes. On the basis of molecular orbital theory, by removal of an electron. So they are saying that in which of the following diatomic molecule the bonding will become stronger if we remove an electron. Oh, by the way, you know that, right? Bond strength is directly proportional to bond order. Yes, the more is the bond order. That means if you have a double bond is stronger than a single bond. If you have a triple bond is stronger than double bond or single bond, right? You're understanding what am I saying? I'm saying that bond strength is, have a look. Bond strength is directly proportional to bond order. It is directly proportional to bond order, right? Now, if we remove electrons, and let's say that we remove the electrons from anti-bonding. So, what is the formula, guys? What is the formula of bond order? The formula for bond order, everybody, if you remember, is bonding molecular orbital electrons, BMO electrons, minus anti-bonding molecular orbital electrons divided by 2. So that means if I take away electrons from the anti-bonding molecular electrons, if I take away electrons from anti-bonding molecular orbitals, then please tell me, will the bond order increase? For example, let's say that I have, let's say that I have 10 minus 6 divided by 2. Now I have taken away one electron from here. If I take away one electron from here, then I will have 10 minus 5 divided by 2. So 10 minus 5 divided by 2 becomes 2.5, right? But 10 minus 6 divided by 2 becomes 2. So as you remove electrons from anti-bonding, as you remove electrons from the anti-bonding molecular orbital, the bond order increases. If bond order increases, bond strength increases, right? If bond order increases, bond strength increases, isn't it? Very good, very good. Now, so we see that in these cases, okay, in all of these, you will notice that only NO and O2, these are the only two molecules where there are electrons in the pi star orbital. That is, in anti-bonding, these are the only two molecules where you have pi star electrons. Other ones they do not have. N2 has 14, N2 has 5 plus 5. N2 will have how many electrons? 7 plus 7, 14. है ना? 7 plus 7, 14. C2 will have 6 plus 6, 6 plus 6, 12. B2 will have even lesser than this. So these other molecules, they won't have electrons in the pi star. That is in the anti-bonding, okay? But here you will have anti-bonding pi star electrons. So if I take away, now have a look for NO, okay, bond order, everybody have a look guys, pay attention. Bond order of NO is what? Nitrogen has how many electrons, oxygen has how many electrons, and calculate it. Bond order of NO is going to be 2.5. Okay, you can calculate this. This has come with practice, that I know that bond order of NO is 2.5. So if I take away one electron, the bond order of NO plus is going to be what? Bond order of NO plus is going to increase by 0.5. So this will be 3. This will be 3, right? Now have a look. Bond order of O2, everybody. Bond order of O2 is going to be how much? 16 divided by 2. No, not 16 divided by 2. You cannot do 16 divided by 2. Bond order of O2 is how much? We know this. Bond order of O2 is 2. Yes. Now, if I keep here O2 plus, what is going to be the bond order of O2 plus? 2.5. 2.5. So the answer is option A and C only. That is C. Option number C is correct. Yes. A and C. Yes. A and C. Absolutely right. A and C is the correct answer. Are we clear on this? Are we clear on this, everybody? Yes, are we? Shall we go to the next question? Shall we go to the next question, guys? What's the scene? Yes, Naga. Yes, Naga, you are absolutely right. It is A and C, right? It is A and C. Okay, okay. Rajini, you are also absolutely right, bacha. CAF, yes. CAF also got it. CAF also got it. Very good, very good, very good. Chalo. Next question for us is, number of electron deficient molecules among the following are. Electron deficient. That means that, do you remember the octet rule in the chemical bonding chapter? We start with the fact that octet rule, yes, octet rule had come, and before that there was what? Kossel and Lewis octet rule and all of that we studied. Then we studied that octet rule is not universal. And why so? Why is octet rule not universal? Because obviously it has disadvantages. What is the disadvantage now? The disadvantage was that there were certain molecules which had more number of electrons than 8 electron, right? There were some compounds which were electron rich, and there were some compounds which were electron deficient, right? They had less number of electrons than 8 electrons, and which is why octet rule did not happen to be a universal law. So now which are the compounds that we have here? First of all, everybody, just have a look at BCl3. The moment you see, I think you will be able to understand that boron has what? 3 valence electron, right? Boron has how many electrons, guys? Boron has 3 valence electrons, correct? Now, after it forms bonds with the Cl atoms, there will still be what? Each Cl atom will give one electron. Boron will also give one electron. In that molecule, you will have 6 electron. Boron does not fulfill its octet rule. Boron will only have 6 electrons. Boron will only have 6 electron. Hence, this cannot complete its octet rule. It is remaining as electron deficient. Very good. Now, if we talk about, now have a look at all the other ones. Have a look at all the other ones, everybody. All the other ones. Yes. Now, you will also see that B2H6. For B2H6, do you remember that this forms what? This forms this 3-centered 2 electron. It forms a 3-centered 2 electron banana bond. Do you remember this? Banana bond, everyone? Banana bond. Yeah, we do remember banana bond. Very good. So, what is the structure here? See, B, then you have H and H here. Then you draw here H, then you draw here B. You have these terminal hydrogens, and here you have H and H. Now, what happens is, here you will see 2 electrons being shared, and here you will see 2 electrons being shared. Here 2 electron, here 2 electron, here 2 electron, here 2 electrons. So, if you count, you will have 1, 2, 3, 4, 5, 6. 6 electrons only. Only 6 electrons. Once again, you will be able to see that this is not, completing its octet. It is electron deficient. Is there anything else? Is there anything else that you want to check out? Have a look. Have a look, everybody. Have a look, guys. Have a look. Anything else? Anything else? Nothing? We are all cool? Yeah? We're all fine? Everybody is fine? Chalo. So the correct answer is here option C. Okay? Option C becomes our correct answer. Next question, everybody. Ready? Next question is LIH can be, actually. LIH can be, but I do want to have a look at it. LIH, no, it will be. LIH will also have, but LIH forms duplet rule, right? LIH follows duplet rule. It will not be electron deficient as such. It will not be electron deficient as such. It will have a duplet rule. It follows the duplet rule. So we cannot really say that it is deficient as such. Okay? Yeah? LIH, Nityashree, I just said na, LIH will follow duplet rule, bacha. It will follow duplet rule. Okay? It will not follow octet rule. It will follow duplet rule. And hence, we will not call it as electron deficient as such. Got it? Yes. What are you confused about, JEE 𝐤𝐴? Yes, tell me, what are you confused about? 2 electron. Yes, 2 electron. Just 2 electron. Yeah, just 2 electron. Explain more about banana bond. Okay, so in case of a banana bond, now boron has how many electrons, guys? Boron has 3 electrons, right? So what happens is, chalo, let me move this way, okay? Let me move this way. I'm going to draw the structure once again. You see boron and boron here, okay? Now boron will give 2 electrons here, okay? It will give 2 electrons here, and it will form terminal bonds. These are what? Terminal. Terminal, you understand? At the end. Terminal are at the end. Both these are, everybody, this and this are called as terminal hydrogen, okay? So boron has 3 valence electron. Out of the 3 valence electron, both this boron and this boron, they are done with sharing 2 electron, right? Now it has the 3rd electron. So what will this boron do? This boron will give 1 electron, and here is hydrogen. So hydrogen will also give 1 electron. Okay, done. Now do you see that this boron is done with sharing its valence electron? It's done? Absolutely done. Now this boron once again will give 1 electron from here, and hydrogen will also be here. So this will give another 1 electron, and they will form a bond like this. But now you see this whole unit, everybody have a look, understand this. This whole unit will come and attach itself to this, because you see that they have less number of electrons. So they dimerize. Dimerize, you understand? Dimerize. Actually, it is supposed to be BH3, but it is not BH3. It goes and forms B2H6. B2H6. Why does it dimerize? Because it has less electrons. So it tries to protect itself, and it comes and forms a bond. But here, right here, when we form this bond, there is no electron that is being shared, by the way, right here. Hence, this is called as, see, you have 1, 2, 3, 3 center, but only 2 electrons are being shared. What did I say? This is what I have written, 3 center, 2 electrons. See, 3 center, 2 electron, everybody. 3 center, 2 electron I have written. This is exactly what I mean when I have written here 1, 2, 3. You have 3 center, but only 2 electrons are being shared. Got it now? Got it now? Yes? Do you get it? So it forms a bond like this, and then this forms a bond like this. This is what happens. This is called as banana bond. Everybody got it, guys? Any doubt here? Any doubt here? Everybody got it? Everybody got it? Clear hai? Chalo. Moving on to the next question now. Which one of the following alkaline earth metal ions has the highest ionic mobility in its aqueous solution? How many of you know this? How many of you know this, guys? I really hope. So we all know that smaller the size of the cation, greater will be hydration. Yeah? If the cation is very small, then what will happen? More amount of water molecules will come and attach itself. And when they attach itself, then the molecule, then it becomes hard for it to move. If greater hydration, less mobility. Understand this. Once again, everybody, understand this. What did I say? First of all, let me write it down and explain it to you. I said smaller size, okay? Smaller the size of cation, greater will be hydration, okay? And if hydration is more, then mobility is less. Now tell me, out of these options, which one of them has the biggest size? Whichever has the biggest size, that will have the highest ionic mobility. Very good. Akshay, Sanjay, Nitya Shri, very good. The answer is actually option D. Now you know that it is beryllium, magnesium, calcium, strontium. Strontium is at the bottom of the group. Strontium will have a bigger ionic radius, and hence the mobility will be more. Okay? Alright? Yes? Got it? Clear, everyone? This is clear? So, Sr plus 2 will have the highest ionic mobility. Okay? Alright? Okay. Chalo. Moving on. Next question is, consider the ions or molecules for increasing bond order. The correct option is, but choose. Do you see that O2, 2 negative, O2 plus? This is a repetitive question every year. Do you guys see this? That this is a repetitive question every year. This is coming. Every year this is coming, everyone. Yeah? Do you see? So, can you all promise me that you will be looking at this particular molecular orbital? That means you will be practicing the molecular orbital theory of oxygen a little more? Can you all promise me this? Can you all promise me this, everybody? Yes? If you do so, trust me, you will be able to get 4 marks. Okay? Chalo, let us have a look at it. Now, we all know that O2 2 minus 16 plus 2. If it is 18, that means in 18 number of electrons, you will have bond order 1. This will have bond order 1. O2 negative, it will be 1.5. This will be 1.5. O2 will have a bond order of 2. O2 plus will have a bond order of 2.5. So yes, option A is absolutely correct. Option A is absolutely correct. Okay, very good. Very good. Chalo, next question. The correct order of increasing intermolecular hydrogen bond strength is. Acha. For this, we have to understand that what happens here is, first of all, CH4 does not form hydrogen bonding. Yes, what did I say? I said that CH4 here. See, what do you have? You have options HCN, H2O, NH3. Then you have NH3, CH4, right? You have CH4. So please understand that CH4 does not form H bond. Okay, does not form H bond. Right? Why? Because the difference in electronegativities, okay, the difference in electronegativities of hydrogen and carbon is very less, okay, so it will not form. Now, what about NH3? In NH3, we see that the difference in electronegativity, in case of NH3, we see that, what do we see? That difference in electronegativities of nitrogen and hydrogen are quite a lot. Yes, the difference is quite a lot. Hence, what happens? The difference in electronegativities of NH is high. Okay, is high. Hence, you will see that the hydrogen bond strength of NH3 is highest. Okay, so H bond strength in NH3 is highest. All right. If that is the case, that means NH3 definitely has to be highest. If NH3 is highest, then I have also written that CH4 is the least. So that means I think option C makes sense. Does it? Option C makes sense, guys. No, option C. HCN will be in the middle, CH4 will have the least, and NH3 will have the highest hydrogen bonding strength. Okay? Alright? Clear, guys? Clear, guys, or not clear? Clear or not clear, everybody? Are we done? Do you guys understand this? Chalo, moving on then. Moving on. Next question. Oh, matching. Who was asking me about VSEPR theory? Who was asking me about VSEPR theory? We wanted a VSEPR theory. Here you have another question on VSEPR theory. So based upon VSEPR theory, match the shape geometry of the molecules in list 1 with the molecules in list 2 and select the most appropriate option. So chalo, not B. No, not B. But I have just clarified, no, CH4 will have the least and NH3 will have the highest. HCN will fall in between. Okay? Chalo, here we have a VSEPR theory. So we have to figure out the shape and the molecules. Chalo, let us talk about XEF4. Shall we? Let us talk about XEF4. Everybody, are you all with me or no? How many of you guys are here with me? XEF4 will have what shape? XEF4. Okay. Somebody was asking, ma'am, how to draw the structure. Yes. Hydrogen bond is very strong. Yeah. Hydrogen bond is very strong. Why not water molecule? Where is water molecule, bacha? In this option, do you see water molecule? Anywhere? Do you see a water molecule? I don't see water molecule. Chalo guys, XeF4, right? So 1, 2, 3, 4. I have drawn the bond pairs. These are my bond pairs. Number of bond pairs? 4. Okay. Now, xenon has how many electrons? Xenon has 8 electrons in the outermost shell. So that means 1, 2, 3, 4. 4 is done, but still 4 electrons are left. So these 4 electrons, I can draw it as lone pair and lone pair. So what will be the shape? The shape will be square planar. Makes sense? Now see, have a look. Have a look how am I drawing the structure. All the students who are asking them how to draw structure, how to draw structure, how to draw structure. This is how you draw structure. Yes? Got it? Why water is... Surya, you are lost in somewhere else, bacha. I have explained this. Why don't you see? Why don't you see? Where is water here? There is no water here in the question, bachu. There is CH4, NH3 and HCN. Now water also has a very high hydrogen bond. Yes. So don't worry about it. Just write down what I have told you. Just write down what I have told you. I have explained it again. I have explained it again to you. Right? Just look at the explanation. What does the explanation say? The explanation says that CH4 does not form a hydrogen bond because the difference in the electronegativity of carbon and hydrogen are same. Hence, there will not be a extra hydrogen bond. Okay. But in case of NH3, the difference between electronegativity of nitrogen and hydrogen will be much higher. Hence, there will be a hydrogen bond. Yes? Hence, there will be a hydrogen bond. Are you getting my point? Yes? Are you getting my point, everybody? Wait a second. Let me tell you. Yes. Now, to all the students who are asking about water, you have to understand that, please guys. Now, water has what? It has hydrogen bonds, definitely. And these forms between neighboring hydrogen and oxygen atoms of adjacent water molecules. Now, water has even higher. See, water has what? Hydrogen and oxygen. Nitrogen comes before oxygen. So, hydrogen and oxygen has even more electronegative difference. And that is why the hydrogen bonding is even stronger. So, ideally, even more than NH3, water should have the intermolecular hydrogen bonding strength. Getting it? Getting it? Yes or no? Getting it or not, everybody? Same doubt. Now clear? So, ideally, if water was here, then we would have considered. But water is in between. That cannot be. Okay? That cannot be. That is why option C is the correct answer. Understood now? Understood? Chalo. Okay. Chalo. Now, everybody, let us have a look at our questions. Shall we? Shall we continue? Shall we? Yes, guys, or no? How many questions do we have? Okay, we have here XeOF2, XeOF4. We will do all that also. But chalo, now let us consider these. Now what do we have for SF4? SF4 is what? SF4. What will be the structure of SF4? Anybody? Anybody, what will be the structure of SF4, guys? Come on. I think you know the answer. SF4. SF4. We saw it. See, for SF4, now this time we know that, see, sulfur has what? Sulfur has one lone pair. Okay, now tell me how many electrons are there in the outermost shell of sulfur. Sulfur is in the oxygen family. Oxygen family, so after oxygen, just below oxygen, you have sulfur. 6 electrons, 6 electrons. So 1, 2, 3, 4, 5, 6. Right? How many? How many times do we have? Oh God, you guys are not at all, very, very hard crowd, yeah? Very hard crowd you guys are, huh? If I spend time and explain you the question, then you're like, you are taking too much time. Bro, I don't have to give the exam. You have to. If you want to learn, spend some time and learn at one go. If you don't want to learn, don't. What can I say? You have to appear for the exam. I'm not giving a speed test. I'm not going to give a speed test, okay? So please understand what I'm trying to do. Okay. Now sulfur has 6 electrons. So I know that here I can directly see that there are 4 fluorine atoms that are attached to sulfur. Right? Yes. If there are 4 fluorine atoms, that means there is one lone pair. If there is one lone pair, that lone pair will push the other bond pair. So it will be FF here and FF here. This will be a seesaw shape like this. Okay. Now what about ClF3? What about ClF3? Who can tell me? Who can tell me about ClF3? And then who can tell me about BF3? For BF3, I think I've already explained it to you guys. I've already explained it to you guys. Can you answer? Or no? What do we have? C is 1, C is 1 and D is a 2. So, what is the correct answer, guys? Come on. Yeah, this will be a seesaw shape. Very good. Now you calculate the other 2s and tell me. Calculate the other 2 and tell me. What about ClF3 and BF3? What about ClF3 and BF3? Come on. Which one has T-shaped? Which one has T-shaped? Let's see. T-shape for ClF3. Okay, if you say so. And what about the other one? And what about the other one? Come on, people. Come on, come on, come on. I think you can do this. I really, really think that you can do this. Come on, guys. And option B is the correct answer, just by the way. But let's see. For ClF3 will be T-shaped, okay? And you have trigonal planar, and that will be BF3. Now your homework is what? What is your homework? Your homework is to find out how to draw the structure of this ClF3 and BF3. I have just explained you XCF3 and SF4. Now you do the other part. Do the other 2. I think you will be able to do it. It should be easy because you already know it. Yes, because you already know it. Just have a look at it and tell me, okay, how to do this. Chalo. Next question, let's do. In the structure of SF4, the lone pair of electrons on S is equatorial position, and there are 2 lone pair bond pair repulsion at 90 degree. Equatorial position, and there are 3 lone pair bond pair repulsion at 90 degree. Axial position, and there are 3 lone pair bond pair repulsion at 90 degree, or is it axial position and there are 2 lone pair bond pair repulsion at 90 degree? How do we draw the SF4, bachos? We draw the SF4 as, see, we draw the SF4 as S here, F here, F here, F here and F here, and we have 1 lone pair here, right? So you have, there are 2 lone pair bond pair, 2 lone pair bond pair and lone pair bond pair. So there are 2 lone pair bond pair repulsion at 90 degree, isn't it? Yes, 90 degree, isn't it? Have a look, guys, have a look. So you have 2 lone pair bond pair, right? This right here you have a 90 degree. And right this way also you have a 90 degree. So at 90 degree, at equatorial position, you have the lone pair, and you can see that there are, this is a lone pair bond pair repulsion, and so is this. This is also a lone pair bond pair repulsion. Correct, everybody? Correct? So option A is your correct answer. Option A is your Correct answer. A, it's not axial. It's in equatorial position. This will be equatorial position, isn't it? Yes. Chalo guys, moving on. Next question everybody. Arrange the following in the decreasing order of their covalent character. Bachos, I think I've already explained you Fayon's rule. The first question was related to Fayon's rule and I have explained it to you. So can anybody tell me? Now you all know that, see, the anion is similar, right? Anion is Cl, 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 Cl everywhere. Only the cations are different, and we know that small cation, large anion, this is your Fayon's rule, more is the covalent character. So obviously option A, lithium chloride, LiCl, will have high covalent character, then it will be B, then it will be C, and then it will be D, because lithium, sodium, potassium, then cesium, isn't it? Lithium, sodium, potassium and cesium. So yes, option C is the correct answer. Are we clear? Yes, option C is the correct answer. Very good, guys. Very good. Chalo. I think. Okay. Number of lone pairs of electrons on central atom and the shape of BrF3 is. What is the shape of BrF3, everybody? What is the shape of BrF3? I believe you guys know it. I really think you know this. BrF3, the structure looks like this, okay? The structure is like this. You have one F here. You have one F here, one F here, and then right here you have two lone pairs. So this becomes, you have how many lone pair here? You have two lone pair, right? You have two lone pair, and what is the shape? The shape is bent T shape. The shape is bent T shape. So what do we say? We say that option C is our correct answer. Yes, option C is the correct answer. Very good. Chalo. Last but not the least, everybody, let's just do this question and after that we are done because I am also super tired. So let's do this. XeO3, XeO3. How do we do XeO3, everybody? Chalo. So we draw it like this. Xe, once again, xenon. Xenon has how many electrons in the outermost shell? 6, right? And we see that there are 3 oxygen here. Now oxygen will form double bond O, and double bond O. 3 oxygen done. But xenon now has formed 1, 2, 3, 4, 5, 6. 6 bonds. There is still 2 more electrons left. Where will those 2 electrons go? Right here on the lone pair. Yes. So this shape, what does it look like? Doesn't this look like a pyramid? It looks like a pyramid. If it is a pyramid and I can see that 1, 2, 3 here, there are 2 lone pair and you can see, so what is going to be the hybridization? Guys, what is the hybridization here? Very good, everybody. Yes, it is going to be sp3 pyramidal. This is sp3 pyramidal. Very good. Now, what about XeF2? XeF2, you will have 1 here, 1 F here, then you will have 1 lone pair here, 1 lone pair here, and 1 lone pair here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons done. Now, what is going to be the hybridization here? What is going to be the hybridization here? Come on, anybody? What is going to be the hybridization? Right here. Somebody can tell me? Are very good. Sangeeta, Aravindan, Kev, very good. It is going to be sp3 dehybridization. sp3 dehybridization, linear. Okay. Now, what about XeOF4? For XeOF4, everybody, once again, we all know that how many electrons? 8 electrons. So 1, 2, 3, 4. Done. Double bond oxygen here. We still have 2 more electrons left and that we can put it here. So now, what is it? Now what is it? Now what will we get? Now what will we get? We will have 1, 2, 3, 4. sp3 and then we will have D2 hybridization, isn't it? sp3 D2 and this will also become square pyramidal. Will it look like sp3 D2 square pyramidal? Yes. Yes. Okay. And finally, we have XeF6, which is nothing but obviously option D, sp3D3. It will be distorted octahedral. Why distorted octahedral? Have a look. Why distorted octahedral? Because you will have Xe here, 1, 2, 3, 4, 5 and 6. Right here, you will have a lone pair. Hence, this octahedral shape will be slightly distorted. That is why we will have distorted octahedral shape. Okay? Alright, guys. Everybody, are we done with this? We are done with this, guys, and it is about to be 8 o'clock. So I basically have taken a session for almost 2 hours now, and I took a session in the morning with the rank predictors test, everybody. So I think today's quota is over. I think you should sit and study, go through the questions once again. I'll be providing you with the PDF definitely in the Telegram channel. Do not forget to join the Telegram channel. Also, my dear students, our Telegram channel is right below this video in the description box. In the description box, you will have our Telegram channel as well as the DPP link. Please do attend it. The DPPs will definitely make sure that you are practicing a little more. Okay, you are practicing a little more. Okay, all the students who are saying that Samanyu, so happy that you already know it. Today I am not going to take care of. Today I'm not telling you how to calculate it. All of these calculations that you have, that 5 bond pair, 1 lone pair, what is the shape? 6 bond pair, 1 lone pair, what is the shape, right? That I'm going to take it in tomorrow's session when I do a flash series, everybody. Okay, tomorrow in the session of flash series where I will be taking care of concepts, questions, theories, tips and tricks, please be there. In that class, I promise I will take you through how to draw the shape, how to find out how many lone pairs are there, how many bond pairs are there. All of these I will take you through tomorrow. Okay, all right? Yes, understand? Rohit, I have just told you, bacha. I have just told you. Oh, thank you, Samanyu. Very good, bacha. So here you will get the DPPs just below this video. Yes, and let me show you here, right here where I'm telling you, yeah. So this is my session, everybody. See, this is my session. Now what you have to do is just click on the more, okay? Just click on this more. Once you click on this more, now what happens is, see, this side there is something that has opened up. Now right here you see the link. Tap the link and attend the quiz. See, so this is your DPP. Here you will be able to solve some questions on your own. Just click on the link or go through Google Chrome, and here you just have to give your email ID or phone number, but it is absolutely free of cost. Okay, it is absolutely free of cost. You can practice on your own, guys. You can practice on your own. Then here is your Telegram channel link. See, Vedantu JEE English Telegram channel link. Just click on this and you will be able to join our Telegram channel. If you join our Telegram channel, you will be getting these notes. Okay, with this note, Tara, bye-bye, Shabba khair, good night, have a nice day, have a nice night, study well, and please practice a lot. Okay.